Our last class, we have started our discussion on effects of taxes on competitive markets, right? And we were seeing the different kind of structures. And this was the last question that I gave you all as a homework. So did any of you give this a try? What are anyone?
Yes, sir.
Okay, Saksham, what are you getting? The answer?
So for the first part, because the average variable cost was coming as a linear function, I took quantity at 0. The value was 1. The which came as the average variable price has to be greater than 1 market price. So for the producer to produce anything,
Okay. And what was the expression of the firm supply curve?
5 into 5 whole into p minus 1.
Okay. Okay. All
Yes,
right.
sir.
And market supply for came as 500 p into p minus 1.
Okay. All right. And anyone with the answer to part 2 of the problem?
Yes, sir. Yes, sir. Equilibrium price was 5 and the equilibrium quantity was 2000.
2000. Okay.
Yeah.
All right. Seems to be correct. So for the convenience of others as well, I'll show you the solution to these two parts once more. And then we will continue with this problem. We are not done with this. I'll discuss a few more things. So let me do one thing. I'll just copy this question out in a fresh page and then I'll start. So yeah. Okay. So let me show you the solution once more. So we are given this is cost function. Ci of Qi is equals to 0.1 Q1 square plus Qi plus 10. So from here, the variable cost is only the first part plus Qi, and the average variable cost is 0.1 Qi plus 1. So what we can observe is that if we plot this average variable cost versus Qi, and average variable cost I, this is linear, right? I hope you all can understand this, with a positive intercept increasing 1. Correct? Others, can all of you confirm me with a yes or no if you understand this? The graph of the average variable cost curve would be looking like this. It would be a positively sloped straight line having an intercept of 1, right? Okay. So that means since this is a linear function, mathematically it does not have a minimum, right? The minimum ABC that we need for classification of the supply curve. So what we will do for economic purpose, we will be taking the minimum possible value on the first quadrant. So for min ABC, you put Q equals to 0 and you get min ABC as 1. Okay, that is what we can see. All right. So that means the minimum price at which the firm will operate or supply in the market is 1. So now let's try to find out the firm supply curve. So now coming to part 1, finding out the firm's supply curve. So for that, we need to write down the profit expression, which is P times Qi minus Ci would be 0.1 Q1 square plus Q1 plus 10. And you will maximize profit by, so this will become P minus 0.2 Qi minus 1 is equals to 0. So P minus 1 equals to 0.2 QI, or QI is equals to 5 whole P minus 1. All right. So that means the firm's supply curve will be small s of P would be 5 into P minus 1 if P is greater than equals to 1, and it's 0 if P is less than 1. Okay. This is your
Sir,
firm supply curve. Yes.
sir, at P, when P is equals to 1, won't it be, won't the quantity be 0?
Yes, Shaksham. You can put the other way around as well. But typically, like it has from a P equals to 1 is basically the break even point, right? So if you put it above or below, that doesn't matter.
Okay, sir.
Okay. But you can do this, it's fine. This would make more sense, right? This is fine. And after the firm supply curve, how many firms are there in the market? There are 100 firms. So the market supply curve would be capital S of P. It will simply multiply. So that will become 500 into P minus 1, P greater than 1, and 0 if P is less than or equals to. Okay. So this is your answer to the first part of the question. The second part says that if the market demand curve is given by this expression, then find the equilibrium price in the market. Okay. So the second one is part 2. So the demand expression is minus 400p plus 4000. So at equilibrium, demand should be equals to supply. That means minus 400p plus 4000 should be equals to 500 into p minus 1. So this will become 500, okay, 4500, and this is 900p. So the equilibrium price is 5. And if you substitute it, the equilibrium quantity is this. Okay. Any other doubts or questions from anyone? So this part is the standard exercise that we do, but just now we did it from the basics of the firm. That's it. Now let's come to the third part in the question. If the government imposes a per unit tax of, let's say, rupees T on the producers, then we want to find the post-tax firm and industry supply curve, and the equilibrium price. Okay, this is the next part. If the government imposes a per unit tax of rupees T on the producer, then find the post-tax industry supply and market supply curve and the equilibrium price. So when the tax is levied on the producers, what essentially happens? It increases the cost of production, right? So now, what is the new cost to the producer? For every unit that it produces, it will be CI of QI plus T times QI. Correct? Every unit of output that the producer produces and sells, it needs to pay a tax of T rupees. So T into QI becomes the total tax that the producer has to pay for producing QI units. Correct? So this T times QI is actually the additional cost, right? So the new cost that the producer has to bear under the post-tax scenario would be the original cost that comes as a part of the production process plus the tax that it has to pay. Right? Can all of you confirm me with a yes or a no?
Yes.
Correct? So that means this is the new total cost that the producers have to bear. So now with this new cost in mind, the first thing we want to find out the firm supply curve. So the process will be the same. I will write down the profit expression and maximize it out. So this will be 0.1 QI square plus QI plus 10 plus T times QI. And you will differentiate this with respect to QI and set it equals to 0. Can anyone tell me what's the derivative giving you to complete the differentiation?
Yeah. P minus
P minus,
in Kostak 0.2 QI
yes.
plus 1 plus T.
Abhishek, I can't hear you. Can you repeat once?
Plus
After
T.
0. Plus T, okay. Yeah. Is equals to 0. So that means P plus 1. Wait a minute. Not plus 1. It should be minus 1 minus T. Yeah. Minus 1 minus T.
Kostak.
P minus 1 minus T is 0.2 QI. So QI is equals to 5 times P minus 1 minus T. Right? Are all of you getting this?
Yes.
So that means the post-tax firm supply curve will be what? Post-tax firms supply curve. Small s of, let's say, P minus T, or rather, let's not change the notation, it's fine. This will be 5 times P minus 1 minus T, but the supply will be only defined when P is greater than T minus 1. Correct? Only then will you get positive supply in the market.
Sir,
Yes.
sir, as we know that, like we have discussed earlier, that supply price is equal to the demand price and market price minus T. So, like we can directly substitute it on a supply function.
To get what, Abhishek?
Like like we have discussed earlier that the supply price is equal to the market price and minus T and a tax. So as we have, yeah, so here we got the same. If we do the same with the which we have calculated, which we have derived the supply from supply function. So if we minus it by T, so it will give the same. So can we do it without doing that? Yes.
Like you're simply saying कि एक minus T बैठा देंगे आप in the
Yeah,
expression, right?
yeah, 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 yeah.
हाँ, logically आप वही करोगे, but आपको समझ के करना होगा कि वो क्यों हो रहा है. Okay, so that's why I showed
Yes,
you the calculation once.
yes.
Steps in between, that's fine. Okay, that won't be an issue. But the last part is over here is crucial, that since the firm supply curve structure is changing, so the part over which it is defined will become T greater than T plus 1, right? because P minus 1 minus T, that entire thing should be positive in order to give you a positive supply. So P minus 1 minus T should be positive, and that implies P should be greater than T plus 1, right? I hope all of you are understanding this. So this is the post-tax supply curve of the firm. So from here, the market supply curve is the exact same way. So the post-tax market supply curve will be
Sir,
capital S of yes.
sir, if we see the graph, then it will be like the price will be greater than average variable cost plus tax. No?
Price will be greater than average variable cost plus tax.
Tax, yeah.
Like
To
the
give a
equilibrium
positive supply.
price,
For,
equilibrium.
for a positive, like for a positive supply curve.
Ha 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 ha.
Yeah.
But Abhishek, a little careful over here. Price greater than minimum ABC plus.
Yes, yes, yes. Yeah, yeah.
ठीक है?
Minimum maybe.
थोड़ा careful रहना होगा because ABC is a
Yeah.
function, so you can't generalize it in that way.
Yes,
ठीक है?
yes. Okay.
So over here, the market supply curve would be 500 into P minus 1 minus T, P greater than T plus 1, and it will be 0 if P is less than equals to T plus 1. Okay. So now with this over here, can we find out the post-tax equilibrium price? Can anyone do that? So for post-tax equilibrium price, what we should do, we should equate the demand curve to this post-tax market supply curve. So that is minus 400p plus 4000 should be equals to 500 into p minus 1 minus t. Can anyone quickly do the calculation and tell me what is the result that you're getting?
Five plus 4 by 90.
Sorry, can you repeat once? 5 plus
5 by 90.
5 plus 5 by 9. Others, can you confirm if you're getting the same?
Yes, sir.
Yes,
Yeah,
yes, yes.
5 plus 5 by 90. Now, one quick observation over here. The government is charging a per unit tax of P, right, on the producers. But what is the effect on the market price? Is the market price rising by T? It is rising by 5 by 90, right? Because if you all can just scroll up and check, in the P-tax scenario, our equilibrium price was 5. So in the post-tax scenario, it is 5 plus 5 by 90. So although the producers are being taxed at the rate of T, the market price does not increase by T directly. Okay, it is 5 by 9 times T. All right. So this is what you often see, might have heard or might have read in textbooks, that price does not increase by the full extent of the tax. Price does not increase by the full extent of the tax. Okay. But just one add-on thing to mention, that is in the short run. Okay. I'll explain it later why I'm writing short run, but at least from the calculation, I hope this makes sense to you, right? The producers are being taxed at the rate of T per unit, but the market price does not increase by T. It is not that it is completely updated by T. It is 5 by 9 times T. So a part of the burden that is given on the producers is getting transferred to the consumers. Okay, that is the idea. So the equilibrium price that you get is 5 plus 5 by 90. So that means if I just try to now plot the entire thing graphically, the usual diagram that we have, the market diagram. So this is quantity over here, price over here, negatively sloped demand, D of P. The pre-tax supply will be something like this.
Sir,
Yes.
like the degree of the transfers, like the price transfers depend on the responsiveness of the market, like the
The
how the
elasticities, yes.
yeah how the
Not the
elastic.
market. Yes, yes, yes. So over here, you can say that 5 by 9 is a little bit more biased towards consumers, right? 5 by 9 is more than 50% of the share of the burden is being given to the consumers. That is what you can say. And the post-tax scenario is something like this. S as a function of P minus T. So this is the equilibrium E, this is the equilibrium E dash. The pre-tax equilibrium P star Q star, the post-tax equilibrium, this one. So this is Q double star, PD star, bring it down, sorry.
The hair supply curve is more elastic, I think.
Yes, typically. So the answers that we got was PS star is 5, QS star is 2000, right? The market supply. And the PD post tax market prices 5 plus 5 by 90. Okay, is it fine? These are the informations that we have got till now. Any questions up till this? Okay, perfect. So if this is clear to all of you, let me put down one more subpart over here, part 4. You want to calculate the deadweight loss due to tax. Does anybody remember which part of the diagram gives you the deadweight loss?
Yes, sir.
Which part? Can you tell me by looking at this?
Yeah, the notation has been not given this. Like,
Okay. Let me put a notation. Let's say this is your E double dash, suppose. Now,
yes, yes, the same.
so it is this part.
Yes.
So we need to find out the area of this part. So deadweight loss is nothing but area of E, E dash, E double dash. Now, how do we calculate this?
So we find the other quantity, so we get the half into base into height formula.
Yeah, makes sense. So what is the other quantity? Can anyone tell me? So we have got the post-tax market price, right? So if you simply substitute that in the demand function, you will get Q double star. So the post-tax price is 5 plus 5 by 90. So in order to find out the post-tax quantity, I can simply substitute it in the demand or the supply function. So the demand function would be relatively easier. Can all of you just put this and tell me what answer you're getting? Yes, anyone?
$16,000 T/9.
16,000 T/9. There seems to be some calculation error section. Typically, the answer should be like you got for the expression of price, 5 plus something, the pre-tax plus something. So in the case of quantity, it would be 2000 minus something. It wouldn't be the entire thing into T.
So it will be 2000 minus 2000/90.
2000 minus 2000/90. Yeah, this looks correct. Anyone else can confirm? Okay. So we have got all the information. That's fine. Now, so we need to calculate the deadweight loss, which is this area, which is half into base into height. So what is the base and what is the height? Can anyone tell me?
Yes, yes. Base is 2000/90 and the height is 5/90, I think.
Okay. Anyone else? अभिषेक छोटा सा गलती हो गया है. Let me show you. आपका ये वाला जो है, let me just bold it out. Base is basically this part, right?
Yes,
This
it has
part. And height is this part. Correct? I hope it's making sense. These are the two things that you need. So the height is basically the gap between these two quantities, right? I can call it as DQ. So this is 2000/90. The pre-tax one is 2000 and the post-tax one is 2000 minus that. So the difference is 2000/90. And the height is basically the difference between the post-tax demand price and the post-tax supply price. What is that? It is T, right? The difference is T. The vertical gap between these two is T. Correct? After the implementation of the tax, the equilibrium price becomes 5 plus 5/90. But that doesn't mean the gap between the demand and the supply price is 5/90. After getting this price from the consumers, suppliers को तो T देना ही हो रहा है, right? They have to give T to the government for every unit that they sell. So the supply price would be 5 plus 5/90 minus T, typically. Correct. So the gap between these two is T. All right. You all can just remember it in this way. I usually remember it. The deadweight loss is basically half into T into DQ. Right. The base is the difference in the prices, which is the per unit rate of tax, and DQ is the change in quantity. Is this making sense to all of you?
Yes, sir.
Any questions? So half into T into DQ. So now you can just substitute it out. DQ is basically 2000 by 90. So that will become 1000 by 9 t square. This is your total amount of dead weight loss. Okay. The more your rate of tax, greater will be your dead weight loss. Okay. That is the idea. And now the final question on this part 5. Find the tax revenue maximizing rate of small t. Okay. What is the tax revenue? Can anyone tell me? Any guesses from anyone?
Yeah, T into Q. T into Q.
Yeah, T into Q, and that is collected by the government, right? For every unit sold in the market, the revenue that the government gets is the tax revenue. Correct. So I basically want to find out that from the point of view of the government, what should be the rate of T that gives the highest tax revenue? Okay. Is it fine? Making sense? So tax
Yes.
revenue by definition is basically T into capital Q, right? Where T is the per unit rate of tax and capital Q is the quantity sold in the market. Correct? So that means we want to find small t that maximizes tax revenue, which is T times Q. Okay. Now, by typically looking at the expression, it seems like higher the rate of tax, more will be the tax revenue, right? For the government. Do all of you agree with this?
Yes, sir.
Correct? So if I tell you that what would be the maximizing T, what would that be? Any answers from anyone? The rate of tax that maximizes government's tax revenue. It would typically be tending to infinity, right? If higher the tax revenue, higher the rate of tax, higher the tax revenue, then that is what should it be? Correct? But graphically, if you look at it, do all of you agree that the part that I'm shading now is the tax revenue collected by the government?
Yes. Yes.
Correct. So that means what is the level of quantity that is being transacted in the post-tax scenario? It is 2000 minus 2000 by 90. This Q double star that you obtained. Correct? This is the post-tax quantity. So that means typically, so this is the output that is getting transacted in the market. So tax revenue would be T times Q double star, which would be T times 2000 minus 2000 by 90. Correct? And this is the expression that you want to maximize. So for maximization, what will you do? You will differentiate the tax revenue with respect to small t and set it equals to 0. Can anyone do this differentiation and tell me what you are getting?
4.5.
Small t, right?
Yes.
Okay, so 2000 So this will be 1 minus 2 by 9t. So you're getting t star as 4.5. That means the tax revenue gets maximized when you charge a per unit tax of 4.5, which is not what we were discussing just a few seconds back. That higher the tax rate, higher the tax revenue. Right? That is what the calculation tells us. Can anyone tell me what might be the reason for this? Or if this is sounding wrong to anyone?
Uh, so reason would be if we will be charging higher taxes, then people's demand will decrease rapidly and there will be less profit received by the government.
People's demand will decrease. Okay. Yeah. That would, yeah, you can say it in that way. But if you simply look at this diagram over here, if you go on charging higher and higher rate of tax, what will happen? The supply curve will be continuously moving left and left. Correct? It will continue to be pushed left. If the supply curve goes on leftward, then what would happen to the optimal output? It will increase or decrease. What will happen?
Decrease.
Decrease, right? So that means the idea is that I'm just writing it over here, that if you go on increasing your rate of tax, there will be two opposite effects on tax revenue. T will increase, but Q will decrease, right? So it might be possible that after a certain value of T, tax revenue decreases. The fall in T dominates the increase in T. Correct? The amount by which quantity falls is actually having a greater impact than the increase in the tax rate. Okay. So this is the reason why you are actually having a finite optimal. Okay. So if I try to draw this graphically, the idea that we just got from here, and the graph that I want to plot is
Producer will be
taking.
discouraged.
Sorry, what?
Producer will discouraged. And they will start
Producer will be.
discouraged to produce because they are
So the end impact is that your quantity, the effect of fall in
quantity will
quantity is more.
decrease. No?
Yes. So there are two opposing effects. After a certain rate of tax, the fall in quantity will overweigh the increase in small t, as a result of which your tax revenue can fall. So typically, if I try to draw this, so this is the equation of tax revenue versus t, right? So this will be something like a parabola. And you are basically having your maximum tax revenue at 4.5. Okay. Is the idea making sense to everyone? Can all of you please confirm me with a yes or a no?
Yes, sir.
Yes.
Okay. And this result, what we discussed, is a very interesting result. And the curve that we have drawn has a special name. It is known as the Laffer curve, which basically shows you the relationship between tax revenue and the rate of tax. And the simple idea is that the curve will not be an increasing one. It will be a concave one. Okay. You will have a finite rate of tax that maximizes your tax revenue. So this is basically an important result from the government point of view, that in order to increase your tax revenue, which will ultimately finance your government expenditure at the macro level, You can't go on increasing the tax revenue infinitely. Okay, there will be a finite rate of tax that you can charge, and beyond which it would be inefficient, not only from the social point of view, but also from your point of view, that is the government's point of view, to raise the level of tax. Because if we are looking at it from the entire social point of view, just have a look at this deadweight loss expression. 1000 by 9 into t square. Can anyone tell me what would be the rate, what would be the value of t that minimizes deadweight loss? Can anyone tell me by simply looking at this expression?
0.
0. Correct. So thinking it from the social point of view, you shouldn't charge any tax. Correct. In order to maximize your social welfare, which is sum of consumer surplus, producer surplus, and government revenue. But even if you want to maximize your tax revenue, it is not that infinite amount of tax revenue, infinite tax rate can give you higher and higher tax revenues. All right, there is a finite amount of tax beyond which it is inefficient for the government also to charge taxes. Okay, so this relationship that there will be a concave curve or a increasing and later on decreasing curve is what is known as the Laffer curve. Okay, any questions from anyone? Is the idea clear? Okay, perfect. So if this part has made sense, so with this question is completed. So we discussed many parts through these questions. The calculation of pre-tax and post-tax outputs, and how are we going to calculate the deadweight loss, and so on. One small thing that needs to be addressed over here, I'll just do it in the note following this. Okay. So in this question that we did, we are having linear equations, right? The demand is a linear equation, the supply is a linear equation. So that is why when we went on to calculate the deadweight loss, we could simply see that it is a triangle and we'd use the formula half into base into height. But what if this is not the case? It is some non-linear curve. Then how are we going to find the deadweight loss? Okay, let us say suppose that this is something like this. The demand curve is something like this, D of P, and the supply curve is something like this. Oh, sorry. Okay, S of P. And in the post-tax scenario, the supply curve parallelly shifts rightwards. Correct? In this case, this will be your deadweight loss. Correct? How are we going to evaluate this? So let us write this down in this way. In case the demand and supply curves are non-linear. Okay.
So we can apply integration here, I think.
Yes. And what would be the expression of the integration? Let me define the demand and the supply curves. So we have P on the vertical axis and Q on the horizontal axis. So I need to define the inverse demand curve, right? Inverse demand curve as P of Q, or let's say I define it as PD of Q to make the notation clear, PD prime negative, and I need the inverse supply curve, which is PS of Q. which is PS prime positive. Okay. So now we have defined the curves. Now tell me, integration of what over what? And let us keep the notation same. Pre-tax output Q star, post-tax output Q double star, pre-tax equilibrium price P star, PD star, PS star. Okay. Yes, can anyone take a quick guess? If you check out this part, the region between Q star and Q double star.
Yes,
Okay.
the function.
The area under the demand curve, I'm just disturbing the diagram, you'll leave it intact, would be this entire part, area under the demand curve, if I integrate. Correct? And in the same part, if I integrate the area under the supply curve, it will be just this part.
Then subtract.
So if I subtract both of them in this part, I will be getting my expression for deadweight loss. So the deadweight loss will be basically integration from Q double star to Q star, the demand function minus the inverse supply function, and the integration needs to be done over the horizontal axis, which is dq. Okay, is the idea clear with everyone?
Yes.
Any questions? Okay, perfect. So with this, the tax part is more or less complete. We'll just have one more question that I'll address in the next part, next class, and with that, we'll complete the discussion of taxes on competitive market. Okay, so that's it for today's class, everyone. Stopping the screen share. Anyone has any questions or doubts? Yes, Abhishek.
So, from where we can get the solution of PYQs?
PYQs of which exam?
ISI, like MSQ.
Like, are you asking for any standard website or anything like that?
Yeah, for standard website or from your parts, like from Saurabh's classes.
Abhishek, like you have we have recorded videos, right, for various questions on the YouTube channel and the portal as well for the PYQs. You can refer to that.
Yes, yes, but they are not from the like
They are not from, sorry, what?
from the 2004 to till now. There are some
They are for some specific questions.
Um, there are like most of them are there. Like possibly some easy questions might not be there, the very simple ones, but the other major questions are there. Okay, in case if you are not finding anything, you all can just let me know. I can just confirm from them if that particular questions video is there or not. But as far as any standard websites or anything is concerned, I haven't seen any till date that has the uploaded PYQs or anything.
okay.
Okay. Anything else from anybody?
Thank you.
Okay then, so that's it for today's class, everyone. Y'all can disconnect. See y'all in the next class. Thank you.